one car, every 5 seconds. Not a concept, not a prototype. A fully assembled vehicle, rolling off the line faster than it takes you to read this sentence. For over a century, automakers competed by building better cars. Tesla just changed the game entirely. While every other manufacturer is focused on the product, Elon Musk is obsessed with something far more powerful: the factory itself. And that single difference may be the reason Tesla's competitors aren't just behind. They may never catch up. For over a century, automakers have competed the same way. You build a faster car, a safer car, a more fuel-efficient car. You improve the product and the market rewards you. That has been the fundamental logic of the entire automotive industry since Henry Ford rolled the first Model T off an assembly line in 1908. But here's the thing about Henry Ford. He didn't win because he built the best car. He won because he built the most efficient system for producing cars. The assembly line wasn't a car innovation, it was a manufacturing innovation, and it changed everything. Toyota understood this too. In the 1970s and 80s, Toyota didn't have the biggest budget or the most advanced technology. What it had was the Toyota production system, a philosophy of eliminating waste, reducing steps, and relentlessly optimizing every second of factory time. That system turned a mid-sized Japanese automaker into the most profitable car company on the planet. Elon Musk has studied both of these stories very carefully, and he believes Tesla is now approaching a similar inflection point, a moment where the company that manufactures best will ultimately dominate the industry, regardless of which company builds the best-looking or most feature-rich vehicle. This is why, while every other automaker is focused on improving the car, Tesla has quietly been doing something more radical. It has been redesigning the factory itself, and the results of that strategy are only now beginning to become clear. To understand why Tesla's approach is so significant, you first need to understand just how complicated traditional automotive manufacturing really is. Take something as seemingly simple as the rear underbody of a car, the structural section that runs beneath the back seats and connects to the rear wheels. In a conventional factory, that single section is made up of approximately 70 to 80 individual stamped steel components. Each one is produced separately. Each one requires its own tooling, its own quality check, its own handling step. Then they are welded together, one by one, using a series of robotic arms in a process that involves hundreds of individual weld points. This process works. It has worked reliably for decades, but it is slow, expensive, and riddled with potential failure points. Every weld is a place where a defect can occur. Every additional component is another variable the factory has to manage. Every extra step adds seconds. And in mass production, seconds multiply into hours, days, and billions of dollars in annual cost. The deeper problem is this. The traditional manufacturing model was designed for a world where complexity was unavoidable. Engineers designed cars around what factories could produce, not the other way around. And for most of automotive history, that trade-off was acceptable. But Musk decided it wasn't. He asked a question that sounds almost too simple. Why are we building cars this way? Not because it's the best way, but because it's the way things have always been done. That question led Tesla down a path that has fundamentally changed what an automotive factory can look like, starting with one of the most powerful machines ever built for industrial manufacturing. The first answer Tesla found was Giga casting. The concept is straightforward. Instead of stamping dozens of separate metal pieces and welding them together, you inject molten aluminum into a single enormous mold and produce the entire assembly as one unified component. One part, 0 welds, a fraction of the production time. Tesla partnered with Hydra, a specialist mold-making company now part of LK Machinery, to build machines capable of generating up to 9,000 tons of clamping force. The result: that rear underbody section that once required roughly 70 individual parts can now be produced as a single cast piece. The robots and welding stations that handled those 70 parts? Largely eliminated. The potential defect points at every weld joint? Gone. Tesla started with a 6,000-ton Giga press for the Model Y rear structure, then scaled to a 9,000-ton version for the Cybertruck, and Musk has since referenced the possibility of a 50,000-ton machine. A number so large it stopped most automotive engineers cold when they first heard it. At 50,000 tons, a Giga press wouldn't just be casting one vehicle section. It could potentially cast multiple structural modules simultaneously, the way a toy factory molds dozens of miniature cars from a single injection run. The reduction in downstream assembly steps would be extraordinary. But casting technology is only one layer of the strategy. The second is the 4T680 battery cell and structural battery pack. In conventional AVs, the battery pack sits beneath the floor as a self-contained unit, essentially a heavy box carrying its own structural housing. Tesla's structural battery pack eliminates that housing entirely. The battery cells are bonded directly into the vehicle floor, becoming a load-bearing structural element. The floor is the battery. The battery is the floor. You've removed an entire category of components, while simultaneously improving rigidity and lowering the vehicle's center of gravity. The third layer is what Tesla calls unboxed assembly, and this is where the manufacturing logic shifts most dramatically. In every automotive factory ever built, a vehicle moves through production sequentially. Station 1 adds the front frame. Station 2 adds the firewall. Station 3 adds the floor. The vehicle travels down the line, accumulating components one section at a time, from body in white all the way to final trim. Tesla's unboxed approach breaks that sequence entirely. Instead of one vehicle moving through hundreds of stations, the vehicle is divided into large modules: front section, rear section, floor assembly, side structures, each built simultaneously in dedicated zones. When all modules are complete, they are brought together for a rapid final join. The practical implications are significant. Factory floor space is used more efficiently. Robots in different zones can work at the same time without interfering with each other. Bottlenecks that once rippled across an entire production line are isolated. And critically, the total time a vehicle spends in production shrinks dramatically. Musk has described the Cybertruck production line as no longer resembling a traditional automotive assembly facility. It resembles, in his words, a high-speed electronics manufacturing plant. Some sections move fast enough that it would be unsafe for workers to operate near them. All of this technology, Giga casting, structural batteries, 48-volt architecture, Ethernet-based wiring, unboxed assembly, is being designed into one vehicle from the ground up. That vehicle is the Cybercab. The numbers illustrate the ambition clearly. The Model Y, Tesla's current highest volume vehicle and one of the best-selling cars in the world, requires approximately 200 major structural components during manufacturing. The Cybercab is being designed with roughly 80. That is a reduction of more than half. Not achieved through cutting corners, but through deliberately engineering complexity out of the product before it ever reaches the factory floor. This is the insight that most discussions about Tesla's manufacturing strategy miss. The 5-second production target isn't something Tesla will achieve by running factories faster. It's something Tesla is designing its way toward by making the car simpler to build in the first place. Every component eliminated at the design stage means fewer robots required, fewer production steps, less time, fewer potential defect points, lower cost per vehicle, and critically, a manufacturing system that becomes easier, not harder, to scale. Giga Factory Shanghai, currently considered one of the most productive automotive facilities on Earth, can produce a Model Y in a matter of minutes through its most critical stages. If the Cybercab launches with the full stack of Tesla's manufacturing innovations in place, the gap between those two production rates will represent one of the largest single-generation leaps in automotive manufacturing history. A better car can be copied. A better battery will eventually face competition. But a manufacturing system built over years, integrating product design, gigacasting, AI-driven quality control, structural battery integration, and parallel assembly is genuinely difficult to replicate. That combination of depth and interconnection is precisely why Musk has always insisted that the factory is Tesla's real product. Most people watching Tesla see a Cybercab, or a Giga press, or a quarterly delivery number. What Musk appears to be building is something else entirely. A manufacturing machine capable of producing millions of vehicles at speeds the industry has never seen before. Whether Tesla achieves one vehicle every 5 seconds remains to be proven. But the infrastructure, the technology, and the strategy are already in place. Tesla's greatest revolution may not happen on the road. It may happen inside the factory, and it may already be underway.